Okay. Hey, everybody. Let's get started. If you guys saw or didn't see, I made another link on the Canvas page. Put this on the other side. And it's like to this YouTube channel that every time we have this class, I'll record the lecture and then I'll post it on YouTube. And then if you guys want to rewatch the lecture, watch any part of it, or if you guys didn't show up, you'll find all the lectures on there. Okay. So yes, let's get started with the material today. So just like pretty much all classes, we're just going to do two sections. We'll start with 1.3 and then finish with 1.4. All right, so 1.3. And believe this whole section, this has to do, let's look at the homework problems. So mainly the slope of a line. So we'll start just by the definition of what is the couple of ways we can think of this slope. So first, let's draw a little graph over here. So say if we have a line like this line's, moving, if we're looking from left to right, like in this direction, the line's moving upwards in this direction. And it has like, a steepness, like the line could look like this. This line's much steeper. This line's much less steep. We could think of, like the steepness is sort of the slope is describing the steepness. And there's a couple of ways we think about it. The first is in terms of just kind of like words. It's going to be rise over run. And what this means is how much does the graph go to the right versus how much does it go up and down? So the right, how much does the rise, how much does it go up and down versus the run, how much does it go left and right? In terms of math, let's put 2 points on here. Let's say this is point, put a point over here as well too. This will be x1, y1. This one's going to be x2, y2. So if we have any 2 points on the graph, doesn't matter which ones, the slope of the line is also going to then equal. So what we do is subtract the y values. So y2 minus y1 over x2 minus x1. And again, it doesn't matter which order. It just matters that as long as there's a 2 here, there has to be a 2 here. But we could do y1 minus y2 over x1 minus x2. You just have to do the same order. But this is fine. We can either do this or, this is going to be the same thing as this, y1 minus y2. It doesn't matter which one you do. And there's another way we can also think about this. Let's say if we have, let's call this, this is just y, how would we say this? Let's not talk about that in particular. Let's draw a new graph down here. Okay, say we have another line on it. All right, and now let's say this is a function f of x. So for example, let's say if this is x2, when we find the function value, you just plug x2 into the equation. So this is going to be f of x2. So this point right here is just going to be x2, f of x2. We can think of f of x, that's just the y value. And then over here, let's say here's x1. So just like above. And here's another point then. This is going to be the point x1, f of x1. So another way of writing slope as well too, in terms of like f of x, we can write this as f of x2 minus f of x1 all over x2 minus x1. So these are a couple of ways if we're given an equation, how do we find slope and stuff. So let's just go a couple of examples. Let's start with do like number 7 and number 8. I guess maybe one thing too we could talk about. So an undefined slope before we get started. So an undefined slope is whenever we have a slope, we have this equation up here, y2 minus y1 over x2 minus x1. Whenever we have 0 in the bottom of the fraction, that means we're going to have an undefined slope. So let's say, for example, we want to find the slope between 2 points. So let's say between the points 2, 7 and 2, 1. So, we have we have 2 points, we have, here's x1, y1, here's x2, y2. And we plug it into the slope equation. Oh, and slope is also the letter m. That's always going to be used for slope. So we have m is equal to, just rewriting the equation, x2 minus x1, oh, sorry, y goes on top. y2 minus y1 over x2 minus x1. But if we plug in these points, so what's y2? y2 is 1, y1 is 7. And on the bottom, we have 2 minus 2. So this is going to be minus 6 over 0, but we can never divide by 0. So whenever this happens, this is an undefined slope. So so the slope in this problem okay? So this is the only time where we're going to have an undefined slope. Remember with the fraction, you can have 0 on the top of the fraction, you just can't have 0 on the bottom of a fraction. Okay. So let's go through a couple of the problems. How about like let's look at number 7. So we're given a graph. The line looks like this. Okay, it gives us this point. This point was 0, 3. And then it gives us this point. This is the point 5, 0. All right, and we just want to know, find the slope of the line. Or what is the slope? So find the slope of the line. So now just like above, we're given 2 points, 0, 3. And we're given the point 5, 0. So we have 2 points on the line. We could just label this. This is going to be, x1, y1. This could be x2, y2. And then just to find the slope of the line, just like above, we're going to plug it into the equation. So m is going to be y2 minus y1, x2 minus x1, which is going to be 0 minus 3 over 5 minus 0, which is going to be minus 3 over 5. So remember how we were talking about too, like rise over run. So what does this mean with rise over run? So in the terms of rise over run, to remember, rise is how much the point goes up and how much we go up and down. So if we're looking at this point right here, so what's the rise? Do we go, so to get to this next point, so to get from this point over here down to this point right here, do we have to go up or down? And we see that we have to go down, and we need to go down 3 units because this is a value of 3. Let's see if I can squeeze this in here. This value on the y-axis, that's 3. So we have to go down 3 units down to here. So the rise is going to be minus 3 because we're moving downwards. And then the run, how much do we go left or right? So if we go right, we have to go right 5 units to get to this. So that's going to be a value of positive 5. So whenever you move to the right, that's going to be positive. If you move to the left, it's negative. If you move down, it's negative, and move up, it's positive, which is sort of intuitive because over here is all the positive numbers. We have positive over here, and then negative over here, and negative over here. But anyway, that's how you would use the rise over run. For the most part, I wouldn't use rise over run. You can just use, because you're always given these, you have to be given 2 points, and it's just almost easier to use just the formula instead of thinking about it in terms of rise over run. But if you were to think about it in rise over run, that's how you think about it for this problem. Okay, what's on the homework? 13, 19. How about, let's do 17. So we have these 2 points, 2 comma minus 2, and 4 minus 2. And we just want to know, what is the slope between the points? So just like always, I think it's always a good first step, even if you have to do this like 100 times, is always start by writing down the equation. This is kind of like a good way to have the equation memorized. So we write down the equation, y2 minus y1 over x2 minus x1. So we're given these 2 points up here. It's good. Let's just figure out which one do we want to call x1, y1. So here's, x1, we can call this one y1, and then this would be x2, y2. And then we just plug everything into this little equation right here. So y2, that's minus 2, minus y1, which is minus 2 as well. And then x2 is 4, x1 is 2. So we get minus 2 minus a negative 2, so that's minus 2 plus 2, divided by 2, which is going to be 0 over 2, which equals 0. So in this situation, our slope, so m, which is the slope, is equal to 0. How about, we can do 27. All right, so what does 27 say? We have f of 1/5 is equal to 1/2. And f of minus 1 is equal to minus 11 over 2. I'm sorry, I did that. 11 over 2. So remember, like, we have this equation f of x. So this number on the inside, this is an x value, and the number that it equals to, this is always a y value. So when we're given these 2 points right here, or these 2 little like equations with an answer and stuff, this is just giving us like an x pair and a y pair. So this first one, it's really like saying we have a pair. We have 1/5 and 1/2. And this one down here is basically saying that we have a point, x is minus 1 and y is minus 11 over 2. So then what we can just do is continue like we did in the previous problems. We can label, this one, this is going to be x1, y1. This is going to be x2, y2. And then just plug everything into our slope equation. So m, which is going to be y2 minus y1 over x2 minus x1. That's going to be minus 11 over 2 minus 1/2 divided by minus 1 minus 1/5. Okay, so what's the top? We'll have minus 12 over 2. And on the bottom, let's just get a common denominator, which is going to be 5. So we have minus 5 over 5 minus 1 over 5. Okay, so then the top fraction is going to be minus 6 because we have 12 divided by 2. And on the bottom, we're going to have minus 6 over 5. All right, so you see we have let's just get rid of the minus sign. So we have a minus sign on the top, minus sign on the bottom, so we can just cancel those out. So we have 6 divided by 6 over 5. And now if you remember, like, when we're doing fractions divided by fractions, we have this top number 6 and we're dividing it by a fraction. How we do that is we just write whatever's on the top. In this situation is just a 6. And then we're going to multiply it by whatever's on the bottom turned upside down. So you take 6 over 5 and you multiply it by 5 over 6. So this is just going to equal 5. So in this situation, our slope is equal to 5. So what we just did here, let's just write this in general to get from this step to this step. In general, if we have a fraction, so say like a divided by b all over c divided by d. So we're dividing fractions. Let's write the d a little bit better. This is going to equal the top fraction, so a divided by b, multiplied by the bottom fraction turned upside down, d divided by c. So in this problem up above, our top fraction, you see how here we have an a over b, but here is just 6. Really, we could think of 6 as just 6 divided by 1. So our top fraction is 6 divided by 1, and our bottom fraction is 6 divided by 5. All right, let's see. So the next thing let's talk about like the equation of a line in slope-intercept form. So slope-intercept form. So what this is just y equals mx plus b. And so whenever we write a line in this form, the m is the slope. So that's going to be the slope of our line. And the b is the y-intercept. In other words, like when you plug in x to be 0, you get the number b. So like if we're going to draw just in general, maybe something like this. This point would be the point 0 comma b. And then the slope, so if this was the line y equals mx plus b, so we would have our y-intercept at the point 0 b, and then the slope would be equal to m. So maybe like an example of a problem that you can do something like this. So say you have something like we want to put 2x minus 3y, which equals 12, into slope-intercept form. So right now, this is not in slope-intercept form. Slope-intercept form has to look like this. We need y on one side of the equal sign, and then just a number times x plus just another number b on the other side. So right now we have x and y on the same side. There's a number multiplied by the y. So we need to turn this. Basically what this problem is telling us to do is we want to turn 2x minus 3y equals 12. We want to turn this into y equals mx plus b. So we need to find our m and we need to find our b. So the way we do that, basically all we need to do is just solve for y. So get y on one side of the equal side and everything else on the other side of the equal sign. So starting, let's just rewrite the problem. 2x minus 3y is equal to 12. So the first thing we can do is we could subtract the 2x to the other side. So we would have, let's subtract 2x, subtract 2x. And this gives us that minus 3y is equal to minus 2x plus 12. And then what we can do is we could divide by the minus 3. Everything gets divided by the minus 3. And so then what we get is y is equal to 2/3 x, then minus 4. So now we just turned the line that we were given, the 2x minus 3y, just from doing like a little bit of manipulation to it, moving the 2x over, dividing by the minus 3. Now we have this line right here is in slope-intercept form. So just from looking at this line now, we see that our m is equal to 2/3, and then our b is equal to minus 4. So if this problem were to ask you, say if you were just given this line right here and said find the slope, find the y-intercept, one way of doing it would be to just put it into slope-intercept form, and then you can just read off the slope and the intercept. So here you see our slope is 2/3, and then our y-intercept is minus 4. So that's sort of like working ahead a little bit from this next question. So say, for example, is 49 a homework problem? I think it is. Yeah, so let's do, say if we were just going to do 50. So this is f of x is equal to minus 2x plus 3. And the problem is just asking to find the slope and y-intercept. So this is already given to us, this line right here, f of x, which equals minus 2x plus 3. This is already given to us in y is equal to mx plus b form. So automatically we already see that our slope, m, is equal to minus 2. And our y-intercept, that's just equal to b, which is going to be equal to 3. Okay. The number 56 and 55, that's like one we just did right up here. We don't need to do that again. Let's do, what's the last question from here? Yeah, let's do 60. So we have 5x minus 2y. Plus 9 is equal to 0. All right, and so just like before, let's find the slope and the y-intercept. All right, let's do this problem 2 different ways, just to give a more idea of how this can work. So remember how, let's first doing it the slope-intercept way. Or we can do it we'll do it the second way. So you remember when we wanted to find, so what did slope mean? This is just if we're given 2 points on a line, it's going to be y2 minus y1 over x2 minus x1. And then what did the y-intercept mean? So the y-intercept, that's just going to be the point that when you plug in 0, you're going to get some y value. This y value is the y-intercept. So in order to find the y-intercept, all we really need to do is just plug in for 0 and solve for y. And to find the slope, all we need is 2 points on the line, and then plug that into the equation. So one way of doing this problem is, well, let's just find 2 points on this line. And in order to find a point on a line, all you have to do is just pick a number, plug it in for, say, one of the variables, and solve for the other variables. So let's talk about the slope. So we need to find 2 points. And notice that a point, on the line x, y, it's just any pair of points, an x and a y, that if we plug it into this equation, we do some things on this side and it gets us to be 0. So let's just let x be, say, 1, for example. So what happens when x is equal to 1? Well, we have 5 times 1 minus 2y plus 9 is equal to 0. So this tells us that, so 5 plus 9, that's 14. So we have minus 2y plus 14 is equal to 0. Subtract the 14 over, we get minus 2y is equal to minus 14. Divide by the minus 2, we're going to get y is equal to 7. So what this tells us is that when x is equal to 1, y must be 7. So a point on a line is 1, 7. So that's one of the points on the line. Let's find another point on the line. How about let's just let x be 0, because that way we'll get the y-intercept. So when x is 0, so here's our equation, we're going to get 5 times 0 minus 2y plus 9 is equal to 0. Now to solve for y, we get minus 2y is equal to minus 9. And then divide by the minus 2, we get y is equal to 9 divided by 2. So this point on the line is going to be the point 0, 9 over 2. So now we have 2 points on the line. We have the point 1, 7, and we have the point 0, 9 over 2. So we can just use these 2 points to find the slope. So we have our slope. We can say this, let's call this one x1, y1, call this one x2, y2. Okay, and now let's find the slope. So we'll subtract the y values. So we have 9 over 2 minus 7, all divided by 0 minus 1. Okay, so get a common denominator on the top. We'll have 9 over 2 minus 14 over 2, all divided by minus 1. This equals minus 5 over 2 divided by minus 1, which is equal to 5 over 2. So our slope is positive 5 over 2. And then also the y-intercept, which we already calculated above. So remember the y-intercept, this is when you plug in 0, what do you get for y? Our y-intercept was, when we plugged in 0 for x, we got 9 over 2. So our slope, or y-intercept, is just 9 over 2. So that's one way of doing this problem without putting it into slope-intercept form. Notice all we had to do here is just we take our equation, we find 2 points on it, and then just plug everything into the slope equation. Another way of doing this problem, let's do it, another solution. So what was the equation? 5x minus 2y. Just is to putting it into y equals mx plus b form. So let's start solving for y. What we can do is subtract the 5x over to the other side. And that gives us minus 2y plus 9 is equal to minus 5x. And then we can subtract the 9 over. Let's do that, minus 9, minus 9. And then we would get minus 2y is equal to minus 5x minus 9. And the last thing to do to solve for y is just divide by minus 2. And then what we get is y is equal to 5 over 2x plus 9 over 2. And so you see we get the same answer. This is the mx plus b form. So we see our m, which is our slope, is 5 over 2. And then the y-intercept is going to be 9 over 2. So the same answer is what we got above. Okay. I think that's good for this section. So let's move on to 1.4. Let's see, what's the first question? 7, 9, 13. All right. Okay, this is basically just adding on to what we just did in the last section. So let's say this, like with number 8. In this problem, we're given a slope, we're given a y-intercept, and then we want to find the equation of a line. So let's say given slope is equal to minus 3 over 8, and the y-intercept is equal to 5, find the equation of a line. So we know the equation of a line. So one thing when we're doing these problems, if at any point in the problem it says find the equation of the line, that just means what we want is y equals mx plus b. So that's always the first part of this problem, is to write this down, because when we're looking for an equation of a line, this is the equation of the line right here. And then the next step would be is, okay, what we need to do is to complete this line is we need to find m and we need to find b. In this problem, it just ends up giving it to us. It says the slope is minus 3 over 8. So it tells us that our m is equal to minus 3 over 8. And that our y-intercept is 5. So it tells us that our b is equal to 5. And now what we do is just plug that into the equation above. So we get y is equal to minus 3 over 8, x plus 5. Okay, we can do one more of those. Oh, let's do number 13. So this tells us that slope is equal to 13, 2 over 9. And the line passes through. Uh, 3, 7. So it doesn't give us the y-intercept. It just tells us that it passes through this point. So just find the equation of the line. Okay. So again, the problem is saying find the equation of the line. So what we want is this. We want y is equal to mx plus b. And now let's see, what does the problem give us? Well, it says the slope is this, and then the point is 3, 7. So right off the bat, we know that since our slope is 2 over 9, we know that the m is equal to 2 over 9. So really what this tells us is that our equation is going to be y is equal to 2 over 9 x plus b. So the last thing to do to find this problem is, well, we need to find b. In order to do that, we want to use our point. So we have this point 3, 7. And remember, whenever we're at a point, this is just an x value and this is a y value. So what we can do is we could plug in this x and y value and then just solve for b. So if we do that, we're going to plug in 7 for y. So we're going to get 7 is equal to 2 over 9. X is 3, so we're going to plug in 3 and then plus b. And so now notice that we just have an equation with one variable, so we could solve for that variable, b. So we're going to have 7 is equal to, and then here we have a 3 on the top and 9 on the bottom. So now it's going to be just 2 over 3. Those 3 and the 9 are going to cancel. And plus b. Now in order to solve for b, we just have to subtract 2/3 over. So b is equal to 7 minus 2/3. So we need to get a common denominator, which is going to be 3. So we'll have 21 over 3 minus 2 over 3, which is 19 over 3. We can't simplify that anymore. So we found our b. Our b, this is equal to b. So now we can complete the equation of the line. So now we know that we have y is equal to 2 over 9x. And then we found out that our b was plus 19 over 3. All right, let's do some more. Let's do 18. So 18 tells us that our slope is equal to 2/3. And the point is going to be -4, -5. All right, so let's do the same thing. We want to find the equation of the line. Okay, so what do we want? We want y is equal to mx plus b. And so we know our slope is 2/3. So we know that m is equal to 2/3. So that the equation of our line looks like this. Y is equal to 2/3 x plus b. And now the next thing we want to do is we're going to take our point, -4, -5. So remember, this is an x value and a y value. And now what we want to do is we're going to put that into the equation over here to solve for b. So we have y is -5. So we're going to have -5 is equal to 2/3 x is -4, then plus b. And so now let's just solve for b. So we're going to have -5 is equal to -8 over 3 plus b. So now what we need to do is add the 8 over 3 to the other side. So this tells us that our b is equal to -5 plus 8 over 3. So getting in a common denominator, we'll have -15 over 3 plus 8 over 3. And that's going to be -7 over 3. So then our b is -7 over 3. So that the equation of our line, y is going to equal 2/3 x -7 over 3. Okay, let's do a couple more. Let's do, we can do, okay, 22. So just find the equation of a line. That passes through -3, 7. And -1, -5. All right, so just like always, what's the problem asking for? That's asking for the equation of a line. So what we want is y is equal to mx plus b. This problem doesn't explicitly give us the slope, so we need to find our slope. But we're given 2 points. So here's one, x1, y1. Here's another point, x2, y2. So all we have to do is plug that into our slope equation. We know slope is equal to y1 minus y2, x1 minus x2. So this is going to be 7 minus -5 all over -3 minus -1. So this is going to be, on the top we'll have 7 plus 5, which is 12. And on the bottom we have -3 plus 1, which is -2. So that's going to be equal to -6. So we found our slope. So now what we know is the equation of the line looks like this. y is equal to minus 6x plus b, since we just found that our slope m is minus 6. So now what we want to do is we need to find b. And remember last time all we did was took that point and then we plugged it into our equation. So now we have 2 points to choose from to plug into our equation to find b. It doesn't matter which one. So just like what I'm saying here, we have this point on the line and we have this point on the line. It doesn't matter. We can either plug this one in here or plug this one in here. It doesn't really matter which one we choose. We'll get the same answer for b. So let's just take the one on the left. So let's take so minus 1 minus 5. And then we're going to plug it into our equation. Y is equal to minus 6x plus b. And so when we do that, so y is minus 5. We'll have minus 5 is equal to minus 6. X is minus 1, and then plus b. So we get minus 5 is equal to positive 6 plus b. Subtract the 6 over, we get minus 11 is equal to b. Okay, and so we have our b is minus 11. And then the last step, so here's the equation of our line right now. We found slope was minus 6, so we had y is equal to minus 6 plus b. So then this tells us that our final answer is going to be y is equal to minus 6x minus 11. Okay, so the next bit, we'll deal with parallel and perpendicular lines. So let's say if we have a line y equals mx plus b. So we know the slope of this line is equal to m. So now let's say if we have another line, y is equal to kx plus b. So we know the slope of this line is going to be equal to k. It's just always the number attached to x. So the slope of the top line is m. The slope of this, let's call this one, I don't know. Let's just put dots here. So we have these two lines. The slope of the top line is m, and the slope of the bottom line is going to be k. So what does that mean for it to be parallel? I guess we can let's number these so we can let's say this is line 1, the top one, and this one's going to be line 2. So we say 1 is parallel to 2 if m is equal to k, meaning that the lines have the same slope. So the lines have the same slope. And then when we say that they're perpendicular, so 1 is perpendicular to 2 if m is equal to negative 1 divided by k. Let's just leave it like that. So this is just the two criteria, parallel. So these two lines are going to be parallel if the slope is the same. The two lines are going to be perpendicular if just the slope of the one line is equal to minus 1 divided by the slope of the other line. So let's do some problems with this. So for example, let's say, so find the slope of the line. That is parallel to y is equal to 4x plus 7. And then we can say, and then find the slope of the line that is perpendicular to y is equal to 4x plus 7. Okay, so for parallel, we saw above parallel, this means this is the same slope. So parallel is the same slope. Well, first let's before we do that, let's write down. So the equation of the line was this: y is equal to 4x plus 7. So we know the slope of this line is equal to 4. So now say if we want to find the parallel slope. We know parallel is the same slope. So the parallel slope is going to be 4 as well. So for perpendicular, so you remember the perpendicular slope is what we do is we use this equation. You do minus 1 over the slope itself. So basically the perpendicular slope is going to be minus 1 divided by 4, which is just equal to minus 1/4. So you just take your slope, do minus 1 divided by that number. Okay, let's do about let's do 36. So we're given these two lines, y is equal to minus 3x plus 1. And then y is equal to minus 1/3 x plus 1. And we want to know, are these lines parallel, perpendicular, or neither? All right, so let's label these lines. Let's call this first one 1, and we'll call this first one 2. So we know the slope of, they're already given to us in slope-intercept form, so we can easily find their slopes. So we know the slope of line 1, that's going to be equal to minus 3. And we can see that the slope of line 2 is equal to minus 1/3. Because remember, the slope is just the number in front of the x. When this is already in y equals mx plus b form. So we already have these in y is equal to mx plus b form. So when that's the case, here's the slope of this line, then here's the slope of this line. All right, so we know the slope of both of them. So let's see. Let's go through, are they parallel? So remember, parallel, that meant same slope. But we can just see here that minus 3 does not equal minus 1/3. So they don't have the same slope. So they are not parallel. Okay. Now how about for perpendicular? Well, remember for perpendicular, we need to have this, one of the slopes is equal to minus 1 divided by the other slope. So notice that we already have, let's write this down. So we have slope of line 1 is equal to minus 3. The slope of 2 was minus 1/3. If we take minus, well, let's look at slope 2. We would, if they were perpendicular, the slope of line 1 needs to equal minus 1 divided by slope of line 2. But let's look at that. What happens if we do minus 1 divided by the slope of 2? We have a minus on the top, a minus on the bottom, so those cancel. So it's just going to be 1 divided by 1/3. But here we're dividing by fractions. So we take our top fraction, which is just 1, multiply it by the bottom turned upside down, which is 3/1, which is equal to 3. But here you see, so what we did here is we took this slope. So what we wanted is so for these lines to be perpendicular, we need that the slope of the first line is equal to -1 divided by the slope of the second line. But we just saw, but the slope of, but -1 divided by slope of 2, we just calculated this, we got +3. And this does not equal the slope of 1, which is equal to -3. So these lines are not perpendicular. So they're not perpendicular. Okay, so that just tells us that these lines are going to be neither. So if you're not perpendicular and you're not parallel, you're going to be neither. Okay, so it takes care of that problem. Let's do 44. So we're given two things here. We're given a point, and then we're given an equation of a line. So say we want to find the equation of a line that passes through -1, 6, and is, we'll do two parts. So part A is going to be parallel to f of x is equal to 2x plus 9. And then part B, perpendicular to the same line. All right, so we have a line that passes through this point, -1, 6. And we want to find first what's the equation of the line that's parallel to this one, and then for part B, what's the equation of the line that's going to be perpendicular to the same line. So for part A, and for both cases, what we want is, we want an equation of the line. We want y is equal to mx plus b. So let's first find the slope. So we need to be parallel to so we're parallel to this line. Notice that this line's already in y equals mx plus b form, so we can easily see that the slope of this line is 2. So this has, so the slope of this line, the slope is equal to 2. And we know parallel is the same slope. So parallel is same slope. So the m that we're looking for is going to be the same thing as that. So m is equal to 2. So we know that our line is going to equal y is equal to 2x plus b. And now we know we passed through that one point also. We passed through the point -1, 6. So to find b, we're going to take -1, 6, and we're going to plug it into this line over here. And so we do that. We're going to get 6 is equal to 2 times -1 plus b. So just by plugging in, this is our x value and this is our y value. And now we're plugging it into the line to the left. And so if we keep solving, we'll get 6 is equal to -2 plus b. Add the 2 over. So we get b is equal to 8. And so the equation of our line is going to be y equal to 2x plus 8. Okay, now let's do part B. All right, again, we're wanting an equation of the line. So we want y is equal to mx plus b. And we want to be perpendicular to f of x is equal to 2x plus 9. So we know the slope of this line. Sorry. Okay, so the slope of this line is equal to 2. And so we know that a perpendicular slope, RM, that means it's going to equal -1 divided by that slope. So -1 divided by 2, which is just going to be -1/2. So now we know that the equation of our line is going to be y is equal to -1/2 x plus b. So now we need to find b, but remember the point that was on the line was the point -1,6. So now what we're going to do is we're going to take -1,6, and then we're going to plug it into this line over here. So remember, this is an x, this is a y. So what we're going to get is 6 is equal to -1/2 times -1 plus b. So what we get is 6 equals 1/2 plus b. So if we add the 1/2 over, we get b is equal to, subtract the 1/2 over. We'll get b is equal to 6 minus 1/2. So now to do common denominator, we'll get 12 over 2 minus 1/2. That's going to be minus 11 over 2. So then the equation of our line is going to be y is equal to -1/2 x minus 11 over 2. Yeah. Okay. So that kind of actually takes care of all the homework problems. Did we do? Yeah, we did enough of those. I think this is an okay place to end it for the day. This this takes care of everything we need to do. Does anyone have any questions on anything in particular? Otherwise, it's fine just to end class right now. Okay. Yeah, so I'll just, once this video is done loading and stuff, I'll post this on YouTube. But yeah, other than that, then I'll see you guys on, I guess, tomorrow morning. Cool. Thank you.